Alright, so now let's talk about solving radical equations and then verifying that it's correct. So to solve radical equations, let's start with this question. As always, pause the video and try all of them. But the first thing we can do is divide out a 3 on both sides. And you're left with square root x is 2 over 3. And then to get rid of square root, you can multiply, basically square both sides. And that would leave you with x equals 4 over 9. And I'm just going to write that here. As our circled answer, so I can make a little bit of space. So now try doing this one. So first thing we're going to do is add 5 to both sides. And we'll get 8 4 root x plus 1, and then divide out a 4 on both sides because this is being multiplied. So the opposite of multiplication is division, and we'll get 2 is equal to x plus 1, and then same idea as before. If we square both sides, we can get rid of the square root. And I'm just going to make another page. So now we will have x plus 1 is equal to 4. Here, I'll just bring it down here. So we are at x plus 1 being squared equals 2 squared. So that's 4, and then x plus 1. And then lastly, we can put in the x plus 1 as being like a minus 1 on both sides to get rid of that, and we would get x is equal to 3. And then to check our answers, we can always put in 3 back into the original equation, or 4 over 9, and we'll get the right answer. Okay, try these ones. So first thing we're going to do again is subtract a 6 to isolate for like the root x plus 1, and we'll get minus 3, and then we have root x plus 1. And just a key point for restrictions, the inside of the square root can never be equal to like a negative number, because you cannot take the square root of like minus 1, for example. So the restriction here, we would set x plus 1 has to be greater than or equal to 0. So therefore, x has to be greater than or equal to minus 1. Okay, so now we have this, and we're going to square both sides to get rid of the square root. And we'll get 9 and x plus 1, and we'll get x equals 8 by subtracting 1 on both sides. And then in this one, interesting enough, if you were to put in 8 into the x and the radical, you would get square root of 9 plus 6 equal 3. So in this case, you would get 3 plus 6, which is equal to 9, but that does not equal to 3. So this is a extraneous root. And that just means that this answer would actually be considered extraneous root, and it's not part of the solution, even though it is technically still within the domain. So therefore the question would actually have no solution. Okay, so in this one, we are going to basically square both sides, and if we square it, we'll be able to get rid of the square root, and when we do that, we will get 2x minus 4 is equal to 3x minus 5. Move everything that has an x to one side and all the constants to the other. So minus 2x and plus 5. So then you would have basically x is equal to 1, and therefore we can plug that back in and see if we get something that is not extraneous. So in this case, if we put in 1, it would be square root of 2 minus 4 is equal to square root of 3 minus 5. And then when we do that, we'd get square root of minus 2 is equal to square root of minus 2. However, this is not solvable because you cannot have a negative number inside of a square root. So this is also an extraneous root.